Okay, so for 8 and 9, the easiest way to do these is to actually just graph out the points. So on your graph paper, you'll just make a coordinate plane if you haven't already. And then we'll graph the points. So the coordinates here, 2, 8, 2, 1, 2, 3, 4, 5, 6, 7, 8. This is point P. And Q is at 5, 3, 1, 2, 3, 4, 5, 2, 3. Got point Q. And then I'm going to connect the dots. So the question wants me to find the distance of that line. Number 9 is the same, so while my brain's on graphing, I'm going to graph these points as well. So A is at -2, 1, and B is at 4, 1, 2, 3. So we have segment AB here as well. Okay, so to find the distance between these 2 points, or the length of this line segment that we just drew, we can sketch out a right triangle. So like just sketch out a right triangle for those 2 points. And then we can use the dimensions of the right triangle in Pythagorean theorem to find the length of this line. So this right here is 3 units, and this is 1, 2, 3, 4, 5 units. And then I'm going to put the work on this paper because if you're studying, you're probably looking at this right here, to be honest. So we're going to put the dimensions here. So I'm going to do 5 squared plus 3 squared equals c squared. And then c will be the length. Oh, it's not focused. Sorry. Okay, 5 squared plus 3 squared equals c squared, and c is the length of that line. So I need to solve that equation, and then I'll have the length. So we get 25 plus 9 equals c squared. 34 equals c squared. And then c squared, to get rid of this square right here, I'm going to take the square root of both sides. And then c equals 5.83. So I got 5.83, but when I look at the answer choices, 5.83 is not there. In this case, they didn't simplify the square root, so you just choose square root of 34. On the test, everything will be multiple choice. On this paper here, the test review, not everything's multiple choice just because I wanted to save space on the paper. But on the test, everything will be multiple choice. Okay, so number 9, same thing. We have our line segment, and we'll just sketch out right triangle. Do that triangle. Okay, there's my right triangle. And the dimensions here, 1, 2, 3, 4 units by 1, 2, 3, 4, 5, 6 units. And then we'll use Pythagorean theorem to find the length of this line. So I'm going to switch over to the paper. And then off to the side, because we're going to use this space over here, I'm going to do 4 squared plus 6 squared equals c squared. 16 plus 36. 52 equals c squared, square root, and c equals 7.21. So I would be looking in the answer choices either square root of 52 or 7.21. Both of those are correct. This is one way to solve for the length of that line. Another way is to use distance formula, which we also practiced in this chapter, and I want to go ahead and practice that as well. So if for whatever reason graphing doesn't work for you, or they give you really large numbers that wouldn't fit on a graph, or they give you decimals, this method wouldn't be the best one to use. So if they give you large numbers or decimals, we want to use distance formula. Distance formula is on the reference sheet. It's right here, so it's nothing you have to memorize, but you do have to know how to use it. So x2 minus x1 squared plus y2 minus y1 squared is this formula here. So to use it, we need to label our points here. So we'll call this x1, y1, and the second set of points x2, y2. And then I will put values into this equation here. X2 is 4 minus x1 is -2. Y2 is -3 minus y1, which is 1. Then use order of operations to solve. Six plus 16. I get square root of 52. That is the exact same number we got over here. So it worked. That would come out to 7.21. And that would be the distance between those 2 points. So, like I said, this method is obviously a little bit easier, but it's only easier when you have numbers that make it easier. So if you get numbers that are too big or decimals, this works too. Or if you just want to check your work, you can do it. Okay. By the way, this is the longest question on the page. I did it first while our brains were fresh, and the rest goes a lot smoother. When you're ready, we're going to go up to number 1. So, I don't want to go too fast. Okay. So number 1 up here, it says how many planes can be drawn through 3 non-collinear points. Non-collinear points are points that aren't in a straight line. It's kind of random. A plane is like a flat surface, and through 3 non-collinear points, you can draw 1 plane. Remember, on the test, you could get a question similar to this that's not quite this. Another way that this could be asked, or a similar question, would be how many lines can you draw through 2 points? Through 2 points, you can draw exactly 1 line. 1 line can be drawn through 2 points. Sorry, handwriting issue. 1 line can be drawn through 2 points is what that says. Okay, then got it. Number 2, it's talking about this diagram here, and it has a couple questions about it. It says which 3 points in the figure are collinear. Collinear points are points that fall in a straight line. Remember, the line doesn't have to be drawn, but they should fall in a straight line. So what I would do for this is go through each answer choice and determine if those 3 points are collinear. So the first set of points is A, B, D. Those are not in a straight line. They make like a triangle. A, B, C. Nope, they're not in a line either. E, C, A. No, not a straight line. F, E, G. Yes, those 3 points fall in a straight line, so that is your answer. Okay, then number 3, it says name the intersection of plane P and a plane that contains points B, C, D. Okay, so plane P, there's a P right here. So the plane P is this plane right here drawn. And then the plane that contains BCD, here's BCD, is right here. But remember, that plane is much bigger than just that triangle. It kind of goes on and on forever. Where do these 2 pink planes intersect? They intersect right here. But remember, planes intersect at a line. So these planes intersect at line BC. Okay, then moving down to number 4. Find the length of segment RS. So here we're measuring on a ruler. Segment RS is at least 1 inch long. Got that. In an inch, there's 16 little dashes. So it's broken up into 16 little parts. You could count that or just remember that inches are broken up into 16ths. Then S is at 1, 2, 3, 4, the 5th little dash. So that means that It is 1 5/16 of an inch. Okay, then number 5, it says, given A is between YZ, and it gives us some values for the segments. The only way to do this without messing up is to draw out the segment. So it says A is between Y and Z. So I would start with point A is between point Y and point Z and draw the line segment. And now, given the values that they gave me, I'm going to label everything. YA is 5.5, AZ is 2x, and YZ is 41.5. So it says find the length of AZ right here. So what we're going to do is find x first and then plug that in to find that length. So this part plus this part equals 41.5. So we'll do 5.5 plus 2x equals 41.5. And then we're going to solve for x. Subtract 5.5, 2x equals 36. And then divide by 2, x equals 18. Then once we have x, it seems satisfying, but it asks for the length of AZ, which AZ is 2x. So we'll plug that in, 2 times 18. So AZ equals 36, and that's the answer that we'd be looking for in the multiple choice. Number 6, it says find the length of PQ. So that's this part right here. It shows the whole thing and it shows this part. Remember, this part plus this part equals the whole thing. So therefore, to find the missing part, we can use subtraction. We can do 38.3 minus 12.6. And that will give us 25.7 centimeters. Then number 7, find the value of y. It says B is between AC, and it gives us values for the segment. So this would be an example where we need to draw out the segment first so we can see where everything lands. B is between AC, so I'm using that as my guide. Let's see, B is between AC. Then it says AB is 2y, so I'll label that. BC is 6y, and AC, the whole thing, is 48. Now that I have it labeled, it's pretty easy to put together, like this plus this equals 48. And so that's what I'm going to do. 2y plus 6y equals 48. Combine your like terms. Divide both sides by 8. And we get y equals 6. Okay, and then once we're done with that, we're going to move up to number 10 at the top of the next column. Ready? No. Okay, number 10 here. Oh, sorry. A second. Ready yet? Just move on. Okay, number 10. Number 10 and 11, we're finding midpoint. I taught you a trick to do this that makes it a little bit simpler than using the equation. So it says midpoint of AB, and it gives you the 2 points. So point A is at 2, 5. And point B, remember to leave a space, is at 6, 9. And then we're trying to find the middle, the midpoint of those two coordinates. So we can look for the middle of the x values. So the middle of 2 and 6 would be what? Anybody? 4. Yeah, it's 4. You were thinking 4. You're right. It's 4. The middle of 2 and 6 is 4. The middle of 5 and 9 is 7. And that's your midpoint. Okay, we're going to do the same method for the next one. As for the midpoint of L and B, L is at 8, 5, and B is at -6, 2. We're trying to find the middle. However, depending on the numbers, the middle might not be so obvious. To some people, depending on how your brains work, you could see that or answer it right away. I'm not that person, so the method to find the middle of 8 and -6 is to add them together and divide by 2. So if we do 8 plus -6 divided by 2, we'll find the middle. So we get 2 divided by 2 equals 1. So the middle of 8 and -6 is 1, which just makes sure that's logical. That seems logical. And then for 5 and 2, some people might be able to do it in their head. But if you can't or just want to check yourself, just find the average of those two numbers, add them, divide by 2. 3.5. Yeah.
You can always do that.
You can always do that. Okay. Then this figure here, it says, what type of angle is ABC? So first we have to identify angle ABC. To identify it, just like connect the dots, and that'll be your angle. So ABC is this angle right here. What they're looking for is either acute, so an acute angle would look like this. A right angle would be straight up and down, like perpendicular, or obtuse, which would be open wider than the right angle. So, based on this, this is obtuse. Okay, so ready for the next one? Number 14 looks a little tricky at first, but I'm going to teach you an easy way to do it. It says find the measure of FBD, so this angle right here. Cool. If FBD and DBE, so this angle here, are complementary, meaning they come together to form a 90-degree angle, so these two added together is 90 degrees. And measure of FBD is twice that of DBE. The best way I think to do this would be just think of it in terms of algebra. FBD is 2 times that of DBE. Like that. And then you can solve for x. So just x plus 2x equals 90. So we get x equals 30. It wants to know the measure of FBD, which is 2x. So we can just do 2 times 30 and get 60 degrees. Okay, then 15. Which pair of angles are supplementary? Supplementary angles, what we're looking for are two angles that come together to form a straight line, like adjacent angles come together to form a straight line. So I would go through each answer choice and find a situation that makes this. So ABE and CBD, those are opposite each other. So no, those are actually vertical angles. ABC and ABD, they overlap. So no. And then this one, ABC right here, and then CBD. They come together to make that straight line. So this is the correct answer. Okay, then 16, trying to make it all fit. I'm gonna have to zoom out. Okay, 16, it says which angle is a vertical angle to ABE. Well, first off, let's review what vertical angles are. Vertical angles are when you have two intersecting lines and the angles opposite each other are vertical angles. So the vertical angle with ABE, looking at here, ABE is right here, would be this angle, which is CBD. So it would be this. Then the next one, if measure of angle CBF is 6x plus 18, find the value of x so that CB is perpendicular to BF. If CB is perpendicular to BF, that means that this angle would equal 90 degrees. So we're going to just set this equal to 90 and then solve for x. 6x plus 18 equals 90. Okay, and last one, number 18, it says find the measure of ABC. It says the measure of ABC is 4x plus 9 and EBD is 7x minus 9. When you look at the picture, just right here, ABC is this angle right here, and then EBD is this right here. These are vertical angles, so therefore they're equal. So vertical angles are congruent. Vertical angles are congruent. So we're going to set these equal to solve for x. Comes out to x equals 6, but it's asking for the measure of ABC, which is 4x plus 9. So we'll do 4 times 6 plus 9 is measure of angle ABC is 33 degrees. And that says all. Okay, so as you finish that up, I know there's probably a few people still writing. Leave the practice test on your desk. I'm going to come around and give you credit for showing all your work and everything. And that way you'll have it with you to study tonight. And then I want you to grab a laptop, log on to Alex, and work on whichever part you're on. But these need to be done by Friday. So go ahead and grab a laptop, leave your practice test out, and